session. And I will be putting these on my YouTube channel. So when I get the video, when I get access to the video, when it's done compiling and all that stuff, and I put it on YouTube, I will send out a link tonight so you can all look at it. All right, let me go ahead and share my screen again. And by the way, if anybody has any questions at any time, please chime in either in the chat or just ask me verbally. Yeah, we have plenty of time to talk about anything you need to during this period. So functions model a relationship between two interrelated qualities. So in this, first example here, I don't really have a context. I don't know what the function f does. I don't know what the independent variable and the dependent variable represents, but I do know that, pretty much by definition, a function relates one quantity to another. So the context will dictate what the quantities are and how they're related. So one of the things we're going to have to be very careful with this semester, and really for anyone going forward, is when you use a function, when you use function notation, what are all those parts, and specifically what do they all mean? So let's look at an example here. So I have a function I'm calling f. Don't really know mathematically how that function works, but I have a function called f. The number of calories that you burn is a function of the number of minutes that you exercise. So here's what I want to do. I have three pieces of function notation here: f of 95, f of c equals 140, and f of z minus f of 40. I'm going to give you all a couple of minutes to do this. For each one of these pieces of function notation, be ready to give me an explanation in English about what each one of those things means. So remember to be careful and be specific. But yeah, right now I have 3:11. At 3:13, I'll come back to you and I'll get a few volunteers for these. So I'll talk to you then. All right, I have 3:13. Does anybody need another minute or two, or are we ready to charge forward? All right, I'm going to take silence as approval. So f of 95. In this context, what do we think f of 95 means?
Would it be a function where a function of the amount of calories you've burned after 95 minutes of exercising?
Okay, so you've exercised for 95 minutes. Actually, why don't you go again? I think I lost you for part of this.
The 95 would be 95 minutes of exercising. So it's saying a function of you exercising for 95 minutes.
Mm-hmm. Okay, so a function of, thank you, Rand. A function of you exercising for 95 minutes. Does anybody else have something a little different or something else they would like to add?
I just put that it was the number of calories burned after 95 minutes of exercise.
Okay, the number of calories burned after 95 minutes of exercise. And I got one in the chat. Ash says, doesn't it represent the value of the calories after 95 minutes? So I think a few of you are saying things that are, different words, but same kind of meaning here. So the way I worded it was the number of calories you burn when exercising for 95 minutes. So obviously there are many, many ways we can express these, but as long as you have the core meaning there, we're all good. How about F of C equals 140? What do we think about that one?
A function of working out for C amount of minutes where you burn 140 calories and then.
Okay, so you work out for C minutes. I don't know what C stands for, but I work out for C minutes and I burn 140 calories. That's good. Thank you, Isaac. Anybody else have anything to add? Okay, I think we're pretty on the money there. You exercise for C minutes and burned 140 calories. And finally, F of Z minus F of 40. What do we have there?
The number of calories burned for an unknown amount of minutes minus the number of calories burned for 40 minutes.
Okay, right. Thank you. So I've burned some amount of calories after an unknown Z minutes. I've burned some amount of calories after 40 minutes, and I'm basically taking that change between them. So the change in calories burned from 40 minutes of exercise to Z minutes of exercise. So I think the way Layla stated this was great. I worded it in a pretty different way, and many of you probably worded it in different ways still that all convey the same meaning. So just to kind of give you a look to the future here, you're going to see this kind of function notation a lot. You might hear it described as the change in a quantity or the difference in two quantities, the net change, things like that. So just, no matter how it's described, be able to kind of go back and forth between the function notation and the English description of these ideas. Any questions on any of these so far? All right, let's move on to something else. So I got another example here. So I want T to stand for the time in seconds since a race car began moving after a pit stop. I want D to stand for the distance in feet traveled by the car since it started moving. So I have two variables here. They're related to each other. I want one of them to be the independent variable for a function, and I want one to be the dependent variable. So which one of these should be independent? Time or distance?
Time should be.
Okay, I hear one vote for time. Anybody else?
Time.
Time, another vote for time. Someone in the chat says time should be independent. Right, so yeah, the three of you who chimed in, you're right on the money. So we want the independent variable to be time and the dependent variable to be distance. So you will find that typically, and I say typically, not always, but typically time is going to be the independent variable. So no matter what the other quantity you're looking at, so it could be, area or volume. In this case, it's distance, lots of things. Usually time is the thing that governs that. So and in this case, it probably makes intuitive sense to you. The more time you drive, the further you're going to go. It's typically easier to figure out which one of the variables depends on the other. In this case, I think it just kind of, hopefully you agree that it makes more sense that the distance you drive is going to be depending on the amount of time that you're driving. So let's do some things with this context. Let's go the opposite direction now. So I've given you these four parts here, A through D. I'm giving you a verbal description in English, and I want you to give me the function notation that matches up there, or that would give that idea. So I have some function called W that represents the distance D at any number of seconds T. So again, I'll give you a couple minutes here. I have 3:19. I'll come back to you at 3:21, and I'll get a few volunteers for the function notation that gives me mathematically what I'm giving you in English there. All right, let's go ahead and continue on here. So part A, the distance driven in the first 9 seconds. What's a good piece of function notation that states that?
The W of t equals d.
One more time, I didn't quite hear that.
W of t equals d.
Here, W of t equals D.
Yes.
Okay, so I believe that is
Wait,
true.
I'm sorry. W of 9 equals d, the first A. Sorry, I wrote it out. I'm sorry. Go ahead.
You're good. So W of 9 equals T. So, sorry. Yeah, W of 9. Yeah, W of 9 equals D. So yeah, I want T to equal 9. 9 seconds is the amount of time that I am concerned with. That is the value of my independent variable. So in fact, yes, W of 9 is what I'm looking for. And I know that I know you said D equals W of 9. You're absolutely right that yes, that is what the distance is equal to at that time value. Well, I'm just looking for the function notation. So if you want to include the D, you're more than welcome, but we don't absolutely need it. All right, B, the distance traveled from T equals 2 to T equals 5 seconds. What do we have?
W of 5 minus W of 2.
Okay, I got a W of 5 minus W of 2. Anybody else have anything a little different? Okay, I'm seeing another vote for W of 5 minus W of 2. Good, so W of 5 minus W of 2. And then the cars change in distance in its third 4-second interval.
W of 12 minus W of 8.
Okay, I have a vote for W of 12 minus W of 8. Ash agrees. Jonathan agrees. I think we're good. So W of 12 minus W of 8. Very good. And finally, the change in distance over any 7-second time interval, which begins at time t equals x.
W of x plus 7 minus W of x.
Okay, so far I have 3 votes for that. Rand says 7 plus x, but that's fine. It's the same as x plus 7. Shannon agrees. Anybody have anything a little different? All right, so I have W of x plus 7 minus W of x. So I want to annotate something because there's another answer I get for this that is very close and that I always have offered to me. So I want to just talk about why it doesn't quite work. So what about this? W of x minus W of x minus 7. So first of all, the thing that I have typed in blue at the top of this slide here, is this going to give me a distance over some time interval of 7 seconds?
Yeah.
It still will. But why is it not correct where the one you all gave me for D is correct?
It finds 7 seconds before you wanted to look at it.
Right.
Or,
So that's exactly right. So what I've typed in blue there, it basically gives me the distance over the 7-second interval that ends with X, which is earlier than I wanted. All right, any questions on these 4? All right, let me go ahead and clear this out so we can move on. All right, now let's switch gears again. So now I'm going to give you the function notation. Let's go ahead and think about how to express these things in English. So again, I'll give you a couple minutes and then I'll come back and check on you very soon. All right, let's go ahead and talk about these. All right, first one, 2W of A. What's that telling us? All right, got some activity in the chat. Isaac says double the distance of the car at 8 minutes, at A minutes. Cheng Che says 2 times the function with the unknown value of A. A couple of things I want to point out there just because, and it's going to sound nitpicky, and it kind of is. When you're talking about function notation or interpreting them, make sure you are totally certain about what the units are. I'm pretty sure that in an earlier slide, I said time was measured in seconds. And those sorts of things are going to make big differences later. So just make sure you know not only what the, for example, if you have a variable that stands for time, how is time measured in what units? If you have a value for distance, is it in feet, meters, inches, whatever? And just if I can kind of piggyback on Cheng Che's answer, 2 times a function with an unknown value of A. So yes, the value of A is unknown, but is that an unknown value for time? Is that an unknown value for distance? So just as a rule of thumb, you can't, so long as it's all correct, you can't ever give too much information. So please be as specific as you can. And Rand, thank you. Yes, seconds and feet were the value of my measurements. Anthony says twice some distance traveled after A seconds. And I think that's a good way to look at it. So twice the distance traveled by the car after A seconds. And I meant to bring this up at the top of class, but I forgot to. When I call you by name, if I am mispronouncing your name or if I am calling you, if you would prefer to be called something else, please let me know. I feel I've taught for quite a long time, and I feel like too many people are just willing to go along with whatever the teacher's mistake is on that. You have a right to be called whatever you want to be called. So yeah, please set me straight early if I'm mispronouncing your name. All right, moving on to the next one, W of C minus W of 8. All right, Ash says the distance over an interval of time between 8 seconds and C seconds. Isaac says the change in distance in feet from 8 seconds to C seconds. So one thing I want to highlight between Ash and Isaac there, the meanings there are basically identical. But Isaac said things are a change and Ash did not. I mean, just, they're both great, but just be able to interpret all these different ways to say the same mathematical idea. Distance traveled between C seconds and 8 seconds, and the change in distance traveled between 8 seconds and sometimes C seconds later. So I want to ask a follow-up question on Anthony's there. That's C, the C value. Is it C seconds after 8 seconds, or is it just C seconds? Yeah, okay, so Anthony, thanks for clearing that up. Yeah, C is just some final value. So let me go ahead and put my wording here. The distance traveled between T equals 8 and T equals C seconds. And like just to reiterate, I've seen a lot of you are saying different versions of the same idea, which is great. All right, next one, W of 7.5 minus 9.
The change in distance the car has traveled during 7.5 seconds when the car starts 9 feet behind the starting point.
Okay. So we have an offset of 9 feet there. In the chat, we have distance traveled at 7.5 seconds after 9 feet. I think that's very similar to what I just heard. Distance traveled in 7.5 seconds when distance is -9. That one, be a little careful with that because it sounds like you're giving me 2 different distances. 1 is the distance traveled in 7.5 seconds when the distance is -9. So we have a conflict there. So just, if you think way back to when you first learned the definition of a function and what it is, if you have an input to a function, how many outputs can you have? Can you have no outputs? Is that possible? Let's use this. Do you all know how to use the reactions at the bottom of the screen here? If you think a function,
Yep.
if you think a function can have one input and no output, give me a thumbs up. Okay, got a few thumbs up. Okay, if you think a function can have one input and exactly one output, give me a thumbs up again. If you think a function can have one input and multiple outputs, give me a thumbs up. So just to recap, a function, basically what makes a function is this. For every one input, so like we'll think about this x and y because that's what we're used to. For every one x value, you can have at most one y value. At most. You usually hear like the vertical line test. It's got to pass the vertical line test, right? The only reason it passes the vertical line test is because a vertical line is a single x value. So it better not hit more than one y value or it's not going to be a function. So remember that was single input means at most one output. And Ash asks, what about ellipses and conic sections? Are those not functions? So what do we think? Let's just stick with a circle. Is a circle a function? It is not. So even though we have equations that, if you probably know or are familiar with the equation that graphs a circle, that's not a function. It's an equation that gives you a graph, but it's not a graph of a function. All right. And Rand is right. You can represent it as two different functions, but not a single one. All right. So back to this one. I think that was a good aside though. 9 feet less than the distance traveled after 7.5 seconds. So obviously mine's different from many of yours, but I think many of your answers were great. And finally, W of 3 plus H minus W of 3. The change in distance in feet for the H seconds after 3 seconds. That's good. Alexandra says the change in distance traveled by the car between 3 seconds and 8 seconds after. I think those are both great answers. So again, like the 1, 2 before it, we're looking at a time interval. So it's the distance traveled in the 8 seconds after the timestamp of t equals 3. Any questions on these 4 before we move on to our last slide here? All right, let's go ahead and finish it off. Right, got a couple more. I will be back at, let's say 3:38 to talk about these last 2. All right, let's go ahead here. So the first one, W of t plus 10 minus W of t. All right, so we got answers from Ash, who says the change in distance over a 10-second interval beginning at t seconds. Isaac says the net change in feet from 10 seconds, the 10 seconds after t. Chance says the change in distance in feet for any 10-second interval starting at t seconds. Those are all great. And Dylan says the distance traveled in the 10 seconds after time t. All very good. So distance traveled in a 10-second interval starting at t seconds. And then finally, this ratio here, W of x plus 0.5 minus W of x divided by 0.5.
Half the distance, double the distance traveled during a 0.5 second interval starting at x seconds.
Okay, good. So I'm dividing by 1/2 is the same as doubling it, sure. All right, so mathematically, that's absolutely what's going on. Starting at time equals x seconds, I want to know how much distance I am going to travel in the half second after that, and then I'm multiplying that by 2. So my follow-up question is, why am I doubling that? Or more specific, to kind of, as a bigger hint, why am I dividing that by 0.5? Let me go to the annotation. I'll try to word this in a different way. So I'm going to keep the top the same, or the numerator the same. W of x plus 0.5 minus W of x and that is all over, I'll put it like this, x plus 0.5 minus x. Does the way I've written this look familiar to something you've seen before? What does it look like?
The average distance.
Average distance, not average distance. Average rate of,
distance.
yeah, average rate of change, or in this context, I'm doing a rate of change of, if you just look at the numerator, what does the numerator represent? A change in what?
Distance.
Change in distance. And the denominator is a change in what?
Time.
Time. So change in distance over change in time gives me what?
Speed.
Gives you speed. So yeah, the reason I'm dividing this by 0.5 is I'm looking for an average speed. Any questions on anything here? All right, that is all I had planned for y'all today. In just a couple of minutes, I'm going to put the password for today's quiz in the chat. But just a couple of reminders. So I will see you all in class tomorrow morning. And I believe Mark has already assigned a couple of homework assignments. One is kind of, I think he just called it day 1 review or something like that. And I think it's due tomorrow morning. If that doesn't sound familiar, please go look, but I think that's the case. There's also a GC homework assignment that doesn't currently have a due date, but I would expect that he's going to make the due date sometime this week. So if you haven't already looked at that, please look at that one as soon as possible, especially for those of you who have not looked at GC or who haven't used GC before. GC is a very, very powerful tool. It's really useful, but it also has a pretty steep learning curve for people who haven't experienced it before. So take a look at that, and if you have any questions, just kind of with the technical ins and outs of GC, please let me know over email, or you can find me in the chat tomorrow morning.
I have a question for you, Mr. Ruiz.
Go ahead, Casey.
So you said that you'll post out a quiz soon?
Yeah, it's actually It's already published. I'm gonna go ahead
Oh.
and stop sharing.
Where can we find that? Is it on the canvas?
Yeah, so you'll be able to find all my recitation assignments in one place. So if you go to Canvas right now, and then click on the assignments heading, when you scroll down, like you'll see homework, lecture quizzes, a bunch of different headings like that. You should see one called recitation assignments, or maybe it's just recitation. At the moment, there is only one assignment for me right now that's published. And it should be called R01 function notation.
And that's
Um,
the quiz that you were
That's
talking
the
about, right?
quiz. It has
Okay.
a password, and I'm going to post the password in the chat, but I have to go look for it because I can't remember what it was. But yeah, Isaac, yeah, R01 function notation is what you want.
Is this in Canvas or somewhere else?
This is in
Oh,
Canvas.
you said you did was in Canvas. Sorry.
Yep.
I was just what I meant was, is this in the same block that the calculus class is in?
Yeah, it's in the same as, oh yeah. So all of the lecture and recitation materials are on the same Canvas.
Okay, so they're in the same like class, so to speak.
Yeah.
Okay.
So the password, I just gave you the password in the chat. It's Macbeth. I'm sorry, go ahead. I cut somebody off. What was your question?
I had a question about one of the previous slides. Whenever you're done speaking.
Okay, so yeah, we're basically done. So I'm gonna stay in the room for a bit if anybody has any questions, or if you have problems getting in. Ash, what wouldn't let you in? Was it the password that was a problem? Has anybody gotten in?
Is the password case sensitive?
Password is case sensitive, so you may just want to copy and paste it from the chat. Okay, good.
I have a question about the actual classroom.
Yeah, go ahead, Rand.
Will the classroom have plugs to plug in laptops, or?
I actually don't know. I have not been to the classroom. I think they all do, but you may want to email Mark and ask for confirmation. But I think all the rooms in that building should be powered. But I would encourage you to. Or has anybody here? Did anybody here attend lecture in person on Monday?
I did.
Do you know if they have power there?
Yeah, there was power.
Okay, good.
Okay. Yeah, I was just asking because my laptop's battery is 100% dead. It just doesn't even charge anymore, which is unfortunate.
That's no good. Okay, yeah, sure. Yeah, but it sounds like they have you can plug in there.
Yeah, you might have to sit like on the edges, but there's plug.
Okay. All right. So yeah, once you've taken the quiz, and if you don't have any questions for me, you're free to go. Otherwise, I'll stay in the room for a bit. Layla, I'm going to pull up that last slide so you can ask me your question. And then Ash. Okay. So Ash, are you in now then? Sweet. All right, I'm going to pull up the
By the way, will this call be recorded?
Yeah, this call is being recorded. So you may not have been here when I mentioned this, but on days where it makes sense, I'll be recording these meetings and putting them on my YouTube channel. So sometime
Nice.
sometime by the end of the night, I'm going to I'll send out the link to everybody to my channel, and this will be on there.
It wasn't on this slide. It was example 1, I believe it was.
Okay.
No, not this one.
Why is this thing fighting? Was it this one, Layla?
No, it was the first example. Wait, let me see. Yes, the
This one
one
here?
before that. No, the
Oh,
one
oh.
before.
Okay.
Okay. On C, I didn't understand the wording. I know this is probably just like basic.
No,
Yeah.
actually, one thing I was surprised by is usually in the past when I've done this example, I've had people be a little confused by it. So, what did you think the answer was going to be for C?
I didn't even know where to begin, actually.
Okay.
I did.
So, basically, what I'm doing for all the time that this car is traveling, I want to break that up into little like 4-second chunks.
Okay.
So like the first 4-second interval is going to be between t equals 0 and t equals 4.
Mm-hmm.
Does that make sense?
Yes.
Good. Then the second one is going to be between t equals 4 and t equals 8.
Mm-hmm.
And then the third one, which is the one I'm interested in, is going to be between t equals 8 and t equals 12.
Okay.
So
And so
if I find
go
the distance that he's traveled after 8 seconds and the distance that's been traveled after 12 seconds, that difference is going to give me what I'm asking for there.
Okay, I get it now.
Good,
Thank
good.
you.
No problem.
Where can we find this exact panel anywhere? These
gonna send
exact.
this- Oh, the slides, I'm going to send that out as well. So by the
Okay.
end of the night, you'll get an email from me that contains the link to my YouTube channel, and it'll have the slides attached to it.
I guess I'll see you next week or the next class.
Yeah, I'll see you in lecture room.
Bye.
Thank you.